Hello dear children, Mrs. Naziya Ustad welcomes you to the second video of the chapter Force and Pressure. Dear children, in this video you will learn about two types of forces, that is contact forces and non-contact forces. A force is a push or pull upon an object resulting from the object's interaction with another object. Whenever two objects interact, each one of them applies force onto the other. But how do the bodies interact? Interaction between bodies can be basically of two types. One in which bodies are in contact with each other, the other in which bodies are not in contact with each other. The forces that result when the bodies are in contact with each other are called contact forces, and the forces that result between the bodies when the bodies are not in contact are called non-contact forces. It's easy to think of contact forces, but it's a little difficult to think of non-contact forces, right? Yes, there are some forces which operate between objects even though the objects are not in contact. We will study about non-contact forces in future. First, we will discuss contact forces. Suppose that you are thirsty and a glass full of water lying on the table. In order to drink some water from the glass, you have to lift the glass towards your mouth. That is, you have to apply force on the glass. How are you applying this force? You are touching the glass with your hand and lifting it. Here, your hand is in contact with the glass. So the force you are applying on the glass is the contact force. Here is an example from the previous video. This player wants to pass this football to his teammate who is standing on the other side of the pitch. The player will apply force on the ball by kicking it. When the player applies force, his foot is in contact with the football. So this force is a contact force. Other examples of contact forces can be pushing up or pulling the desk from one point to another point. Here, our hands are in contact with the desk. Similarly, pressing the keys on the keyboard, moving a piece on the chessboard are some of the other examples in which parts of our body are in contact with the objects and apply force on them. In all the examples that we have seen till now, it is the part of our human body which is in contact with the objects. The forces generated due to our body being in contact with the objects are called muscular forces. The muscles in our body expand and contract when we are applying force on the objects. Animals also use muscular force to carry out their physical activities. A bullock cart is used to carry a load from one point to another. Bullocks are tied with the cart and the load is then added on to the cart. The bullock then applies a muscular force on the cart and moves it forward. So muscular force is a contact force. There is another type of contact forces, that is force of friction. Let's discuss what is force of friction. Try rolling a ball on a horizontal plane surface. What did you notice? You notice that this ball gradually slows down after some time and eventually comes to rest. Why does this happen? Why doesn't the ball continues to move in same direction forever? The reason for a slowing down and ultimately stopping is the force that the surface applies on the ball when it's moving. Yes, the surface applies the force on the ball and the direction of this force is opposite to that of the motion. So when the ball was traveling towards the right, the surface was applying a force on it towards the left. The force applied on the ball by the surface is called the force of friction or simply friction. Friction plays a vital important role in our daily life. We can walk and run because of friction. How does it help us to walk? When we walk forward, we push the ground with our foot in the backward direction. In return, the ground exerts a force in the forward direction which moves us forward. The force which the ground exerts in this is nothing but the force of friction. The examples that we have seen till now are the ones in which the frictional force exists between solid objects. Now consider a boat moving in a quiet lake. In order for this boat to move, the person in the boat must continuously row it. Now if he stops rowing it, will the boat move forward? No, just like the rolling ball stops at the solid surface, the boat will also stop eventually in water. It stops because of the force of friction between the water and the surface of the boat, which is in contact with the water. So, from all the examples which we have seen in this video, what can you conclude about the force of friction? Is it a contact force? We see that the first example, the ball was in contact with the surface. In the second example, the foot was in contact with the ground. And finally, the boat was in contact with the surface of water. So we can safely say that force of friction is a contact force. Till now, we have been studying contact forces. These are the forces in which contact between objects is necessary for the force to operate between them. Muscular force and force of friction are the examples of contact forces that we have discussed previously. But is contact between objects always a necessity for the forces to come into play? Let us find it out. Take a bar magnet and place it on the table. What is a bar magnet? Well, we all know what magnets are. Bar magnet is an artificial magnet which has this shape. Place an iron nail on the same table at some distance away from the bar magnet. Now move this bar magnet towards the nail like this. Keep moving the magnet slowly closer and closer to the nail, but make sure not to touch the nail. What did you notice? When the bar magnet was sufficiently close to the nail takes a leap towards the magnet and sticks to it. What does this tell us? This shows that the magnet attracts the nail and the contact is not necessary for this attraction. The magnet pulled the nail towards it even though it was not in contact with the nail. The force that this magnet exert on the nail is called magnetic force. So contact is not required for the magnetic forces to come into play. We call this force a non-contact force. Now if you bring the magnet close to your iron cupboard, you will get the same results. As you move this magnet closer and closer to the iron cupboard, the magnet will attract towards the cupboard itself and vice versa. However, in this case, it is the magnet which will shoot out of your hand and stick to the cupboard. Are there any other contact forces besides the magnetic force? When you release an object, say a plastic ball, from some height above the ground, it just falls on the ground. Why does it fall towards the ground? This is because of the force that the earth exerts on it in the downward direction. The earth always pulls the objects towards it. This force that the earth exerts on object is called gravitational force. This force is attractive in nature, that is, it attracts two objects towards each other. When you open a tap, water begins to flow downwards. This is because of gravitational pull of the earth on water. Now I want you to tell me, is gravitational force a non-contact force? Yes, it is. We can clearly see from our examples, the contact is not required between the earth and the other objects to attract each other. We say that gravitational force is a non-contact force. Take two balloons and suspend one of them in the air by means of a thread. Hold the other balloon by a thread tied to its end and bring it near the other balloon which is suspended. What do you notice? Do you see anything force between them? Nothing in particular. Now rub the free balloon which is in your hand with a woolen cloth for some time. After that, bring it again near the suspended balloon. Do you see anything strange now? Yes, both the balloons seem to be coming towards each other. We can say that they are attracting each other. Why is this happening now? It's happening because of the force that acts between them. The force is attractive in nature and this attractive force was not present initially before rubbing. Something must have happened to this balloon after we rubbed it with the woolen cloth. We can say that this balloon has acquired something from cloth after rubbing, and that something is what we call electrostatic charge. Let me repeat, when we rubbed the balloon with the woolen cloth, it acquired some charge. So this balloon gets charged now, and this charge is responsible for force of attraction between two balloons. What about the suspended balloon? We call it the uncharged balloon since it has no charge. It doesn't have any charge as we have not rubbed it with anything. Now rub the suspended balloon also with the woolen cloth. It will also get charged. So we have two charged balloons now. Bring them together. What did you see now? Both the balloons are moving away from each other. That is, they are repelling each other. Again, they are repelling each other because of the force which is acting between each other. But here the force is repulsive in nature. What did you conclude from these two experiments? In the first case, the force of attraction between charged and uncharged body, and in the second case, the force of repulsion between both the charged bodies. In fact, whenever we rubbed two bodies together, both of them acquired charge. Then this charge attracts or repels in or charged or uncharged body when brought nearer them. The force exerted by a charged body on another charged or uncharged body is known as electrostatic force. The electrostatic force can be either attractive or repulsive in nature. Now I want you to ask a question for me. Is electrostatic force a non-contact force? Yes, it is a non-contact force. We saw that the contact was not required for the balloons to move away or come towards each other. Here is one more experiment you can perform at home. Rub your hair with comb for some time and then bring this comb near the pieces of paper. The small pieces of paper gets attracted towards the comb. Why are they attractive to the comb? Can you tell me the reason for this? When you rub your hair with the comb, it acquires some electrostatic charge, and this charge was responsible for the electrostatic force of attraction between the small pieces of paper and the comb. Dear children, let us conclude this video and further concepts will be learned in the next video.